Welcome to Insight Builder channel, Solopreneur's Secret Weapon, Developing Microservices Web App with Agentic IDE, Part 7b, 4 Key Design Principles of Microservices. In Part 7a, we discussed what is a scalable application, and also we discussed varieties of things about microservices and the challenges of scaling. One of the important points we discussed in Part 7a was the 4 key software design principles, that is dependency injection, separation of concern, inversion of control, and open close principle. And all of these things we are going to see with example with help of Cursor IDE in this discussion. Let's now dive in. To begin with, we have the Cursor IDE here, and we are going to understand a couple of things. First thing is that you can learn everything about microservices and the concepts, or the 4 key concepts that I was talking about, using Cursor IDE. The 4 key concepts that, again, let me repeat: DI, SOC, IOC, and open close principle. But to do that, you have to first of all know that these things are available. So that's why I'm making this video. No doubt about that. The best way to start working with Cursor IDE is to first of all ask for a simple service that is not following any of these software design principles. So that such a program is what you see here. So a tightly coupled application or a tightly coupled Python script is having a simple database service class, and it is having a user service class. You can see that here, and each of this is separately creating a service or an instance. So here you can see that the user service class is instantiated here, and it is getting the user. But if you look at the user service class here in the self.db service, it is actually calling the database service directly. So when we do like this, meaning if your database service changes, then your user service will automatically change. So there is a strong coupling between the database service class and the user service class. This coupling will create a lot of challenges if you are going to create a microservice from this application. To give you a real world example on how a tightly coupled application looks, so here's an app.py. It's a FastAPI based server, and you can see that it is a single long server file. And if you look at the varieties of services, you can see there is a get user service, there's a get order service, there is a create user, and subsequently get user, the CRUD operation on the orders also, right? Now this is a very tightly coupled single monolith server. So that is a difference. Like this is a monolith and it is tightly coupled, and the same way here is a Python class based program which is also tightly coupled. What we will do is, in this series of video, we will see how we can break this tightly coupled code into individual services, right? So let us actually dive into the details of it. First, we need to understand how the dependency injection works. In order to work with the dependency injection, we have to think about creating functions and methods and inject the database through the arguments. So you can see that in order to inject the database into the user service, we are simply creating a database service from the outside, from the code. So we are creating the database service in the main code, and we are injecting it as a argument into the user service when it is initializing itself. So that is how the dependency injection works. And this dependency injection can also be further abstracted by FastAPI like frameworks. So that is done in the backend. So you don't need to really understand how the backend works. The IDE will take care of it because it's going to implement everything for you. But the point is, you need to know that at the base level, this is how the dependency injection works, right? So when it is tightly coupled, you are going to have the database service directly created inside the initialization of the user service. When it is injection, when the dependency is injected, it is going to be as an argument for the initialization method. right? That is dependency injection. I'm giving you a very brief example so that you can easily visualize what's happening. Once you visualize how the data is flowing and how the classes are developed and how the classes are structured, it's way more easier for you to manage whatever the code given by IDE. Next comes the let us go back. We need to next think about the separation of concern. The separation of concern comes whenever you are going to have separate domains. So you have a user service domain, you have a order service domain, you have a authentication service domain. So that's where the separation of concern comes. And here, these separation of concern helps you to completely organize the code. So in order to see how the code is organized, you can take a look at the better organization of code by using separate classes. So there's a separate database class, okay, which connects and disconnects. There is a separate user class, user repository class, which works on fetching the user and connecting with the database. Again, here the dependency is injected into the user repository. And we have a user service, which is creating an user repo instance. You see how the concerns are separated. The user repository only takes care of the CRUD, that is create, read, update, and delete operations on the user, and that is connected to the database. And the user service only fetches the user. It does not do anything else. So the concerns are separated. This is concerned doing the CRUD operation, this is concerned with the database connection, and the user service is concerned in presenting the data to the user. Right, and all of these things are again made into a single whole using the inversion of control. So we will look into that in the next step. So inversion of control is where all the services that is available is registered to a central location. So in this case, the central location is basically a IOC container or a class which takes the service name along with the service class, and you can pass it to the main, and you can get everything done from there. If this is overwhelming, don't worry about that. You need to take this individual code and you need to execute them. Then you will be able to understand it in detail. The point I wanted to make here is that you are going to use the agentic IDEs, right? Having the knowledge of the key principles is one of the starting points. There are a lot of discussions that is already there in the YouTube. My only intention here is to show you how to use it with the agentic IDEs. Let's go back, and we saw about the inversion of control, and then we'll look into the open close principle. Let us go to the code, and in the open close principle, what is happening is you have a payment processor. So this is one of the meta class, or it is one of the starting base class, and it has a method called process payment. When you're going to extend this class, because according to the open close principle, you cannot remove or edit this payment process method. You cannot change the name, or you cannot change the name of the class, etc. It's closed for editing, but it is open for extension. So in case of credit card payment processor, you can inherit the payment processor, and you can still have the payment processor process payment method, but it will process the credit card payment. And in case of PayPal payment, you will again inherit the payment processor, and you will have a method called process payment. And you can take all these methods and you can still get the process payment done. This is one of the ways where you can work with the open close principles. So in this brief discussion, we rapidly introduced dependency injection, separation of concern, inversion of control, and open close principle. We need to understand these principles, and next what we are going to do is we are going to see how the single app, so the app that you saw here, app.py, we will see how it is disintegrated into separate modules, and then we will, in the next video, we will see how to create services from these separate modules. So let us now dive into the next part. So here we see this is a FastAPI server, which is having an app, which is also having a database that is going to connect. So the database is still separate. So in this case, what has happened is I have already separated it into individual repositories or individual modules. So the db.py has the database connection, and then we have the models, which is having the table details. Then we have the repository or the repo.py, which is having the classes that do the CRUD operations on the order as well as the user. And then we have the services module, which does the presentation of the actual output, right? So here we saw there is a very large server, that is app.py, which is having individual modules, right? This is, you must have already seen the MVP modules or the MVP based applications in Express and Python also, where the model presentation and the logic layer is available. But here it's a little more different. So individual modules have individual work to do. Models have the work of defining the tables, repository has the work of doing the CRUD operation on the table, and the services has the responsibility of presenting the data to the user, right? We see these things available, right? We have already separated the concerns. But when you actually create the server or create microservices, what will happen is you have to further segregate this module into a more modular and more decoupled fashion. Because here, if you see, even though we are trying to use dependency injection here, so we are creating the user repository as a parameter to the user service. You can see that here. And if you go to the repo, you can see the DB session is also dependency injected. We are not manually creating the databases anywhere. And if you go to the db.py, you can see there is a function that returns or yields the database. So that is how the dependency injection works in case of FastAPI. And it is a part of FastAPI, so you don't need to implement this by yourself. So dependency injection is almost taken care by FastAPI itself. Next, we saw how the separation of concern is done using the varieties of modules, right? And next is the inversion of control. In case of the services that you have here, we don't need the inversion of control because all the services are available in the single location. So the server knows that there is orders method, and there is users method, and there is a get order service, get user service, etc. It knows, the main application knows this. But when you are going to separate it into microservices, that's when the inversion of control comes into picture, right? And another one point that you will think about is the database. In case if you are going to change the database, instead of using SQLite, if you are going to work with Postgres, then all you need to do is change the database related module, and the rest of the application will still keep working. It will not be losing any of the services, or it will not lose any of its features, right? But the database is decoupled. So that is one of the benefits of dependency injection, right? So these kinds of things are all taken care with help of the Agentic IDEs itself. And in fact, all this code was written with Agentic IDE to show you how it can be done. Now, the point I want to make here is that we have to discuss all of these things, right? Only thing we are yet to discuss is how to use the open close principle and how to further separate the services that you see here. If you go to the services.py, you see there is a user service and there is order service, right? These two services are still going to be sitting inside the app.py. We need to find a way to break this entire app.py into simpler services. So that is when the actual microservices comes into picture, right? And that is when the inversion of control and a better separation of concern actually comes into picture, right? We will look into these things in the coming videos. So in this video, we reviewed the 4 key software design principles. We looked at the examples in 2 ways. We looked at the example as Python classes, and we saw how a tightly coupled Python classes will look, and then we segregated into varieties of modules and varieties of dependency injected, inversion controlled classes, right? And then we looked at a complete monolithic FastAPI server, and then we broke it into individual modules. We made it into modular first, right? Next, in the next video, we will see how to make the modular into microservices. So I believe in this video you got a very fast and brief introduction on how we can develop microservices based on agentic IDEs with their only support for coding. But from your side, you need to understand how the actual logic and how the key software principles work. So you need to understand these things. I believe that this video must have given you the brief overview of all of these things in this short span of time. I know that these videos are pretty overwhelming if you are new to the software design principles. At the end of the day, we are going to be in a different era, right? So I believe that if you have further questions, do leave it to me in the comments. And also, if you have further ideas, or if you want me to look into new ideas, do leave a comment. I will try to look into that. Subscribe to my channel so that you will get some updates on the next couple of videos that's going to come into this series. With that said, I would like to leave this video with 4 words, that is practice, practice, explore, explore.